Good morning, friends. In today's lecture we will discuss about heat exchange between two finite black surface by radiation. We all know what is the black surface. It absorbs 100% and also emit more radiation. Now we have to find the heat transfer equation or net heat transfer between one surface to another surface. We all know the heat transfer equation for conduction and convection. Now we will find it for the radiation. Now consider these two surface or two area. Between them heat is transferred by a radiation. This is the area 1 and this is the area 2. Heat is transferred or heat is emitted from area 1 in all direction, and few of them is transferred to area A2. Similarly, A2 is emitting radiation in all direction and few is transferred to the area 1. So this both we will discuss in this theory. Now before that, I am discussing some important topic about this theory, that the radiant heat energy exchange between two surface by is always depends on geometric arrangement between two surface. We already discussed solid angle. If heat is transferred from one body to another body, then the solid angle is major important part to find the radiation or heat transfer due to radiation. The second things which is depends that medium between both surfaces. We all know that there is we don't require any medium to transfer heat by a radiation from one surface to another surface, but if something is present between them, maybe gas or vapor or anything, that if the radiation is transferred from one surface to another surface, it may be absorbed, scattered, these waves because of that molecular present between these two surface. And last is characteristics of surface. If the surface is very smooth, then or if the surface is very dull, the radiation is different. Now for this theory, we are assuming that this is the black surface and it is a perfect absorber as well as emitter. And the second assumption is radiation is in vacuum or in air as a medium which does not interfere with the radiation at low temperature. So the as we discussed, it is if the medium is present between them, then radiation may be different. So in this case we are not considering this interface, and we are considering a perfect or a black surface which is perfect absorber and emitter. Now we have two area A1 and A2. The figure already I discussed. Now the angle, this is the normal for area 1 and this is normal for area 2. The angle is between normal and the line joining this both surface is beta 1, and same way it is beta 2. The distance between this both area is L. So solid angle subtended by area or dA2 and on dA1, we are considering one elementary area here dA1 and here dA2. So we already discussed in our previous theory, it is d omega 1 2 dA2 cos beta 2 upon L square. Also we know the rate of intensity of radiation emitted by dA1 in direction of dA2 is from Lambert cosine law. It is I is equal to In cos beta 1. For the black surface we are taking IB instead of In. Now the rate of radiant energy leaving area dA1 that strike dA2 is dQ, rate of heat exchange. Now intensity is IB1, so intensity, the fraction of that intensity is transferred in second body. It is depends on solid angle, so we are considering solid angle here, and also it depends on area intensity. It is intensity per area, so we are considering multiplying the area with it. So we know the equation of solid angle, it is dA2 cos beta 2 L2 L square, and IB we are considering In is equal to In cos beta. Here we are putting IB1 cos beta 1, and we are considering elementary area, so area is dA1. Now we know EB1 is equal to pi into In, and we are considering IB instead of In, so we are putting IB1. Now IB1, taking IB1 as a subject, so IB1 is equal to EB1 upon pi, and E is equal to, so the radiation is equal to, according to Stephen Boltzmann law, it is sigma T1 raised to 4. So here we derived this value or equation for IB1. Now put this equation in equation number 1, so we will get this equation. Now further theory we will discuss in our next lecture. Thank you.